Okay, statistics, we're going to pick back up with lesson 4.1. So yesterday we stopped on this slide right here. We found the average of our probability distribution. So we found the mean, it was 2.6. We're going to use that mean here in a little bit when we find the variance and the standard deviation. All right, this is the formula for variance. You do need to write that in your notebook. This is the formula for standard deviation. It too needs to be written in your notebook. All right, here's their example. So this was back to the probability distribution on passive-aggressive traits. Their mean was 2.94. So this was from an earlier example. What you do first is you take each x value and subtract the mean, just like we did standard deviation before. And then what you're going to do is you're going to square. So we're actually going to add in another column right here. And then we're going to add in yet another column and multiply that by the probability column. So once you do that and you add them up, then you'll get this variance right here. If you take the variance and take its square root, you'll have the standard deviation. And notice they rounded again to 1 decimal place. Okay, so we're going to do that for our example. So I've made a chart for us. All right, the probabilities we had earlier were 0.16, 0.19, 0.15, 0.21, 0.09, 0.10, 0.08, and 0.02. Okay, you're probably wondering where those came from. They're back on slide 17. So if I go back, that's right here. So it's these same probabilities. Okay, moving on. We highlighted our mean earlier. It's 2.6. So now we're going to take each x value and subtract 2.6. And so we'll get these values. Okay, so that's no big deal. Remember, your mean was 2.6. Okay, then we're going to square this column. I'll go ahead and put that in a new color. 6.76, 2.56, 0.36, 0.14, 2, oops, back up, 0.16, let me fix that, 2, let's see, 1.96, 5.76, 11.56, 19.36. Then we're going to multiply these two columns together, and that's what's going to go here. 1.0816, 0.4864, 0.0540, 0.0336, 0.1764, 0.5760, 0.9248, and 0.3872. All right, we're going to add up all of these entries. And that's 3.72. All right, that is your variance. And then we're going to take the square root of that to get our standard deviation. And if we take that in our calculator, the square root of 3.72 is about 1.9. Okay, all right, so there's our variance and our standard deviation. So what does the standard deviation mean? It means most of the data values differ from the mean by no more than 1.9, and these were sales that a person made in a day. So there's your interpretation. Okay, we're going to move into expected value. Out of everything in this lesson, I find this to be the most interesting thing. The mean is the same as what we call the expected value. All right, and one of the most practical applications of this is finding out how much money you're actually losing when you buy a raffle ticket. And so here's an example. At a raffle, 1,500 tickets are sold at $2 for 4 prizes of $500. So let me back that up. You're selling $1,500 or 1,500 tickets. They're $2 a piece. You could win a $500 prize, a $250 prize, a $150 prize, or a $75 prize. You're going to buy one ticket, and it says, what is the expected value of your gain? Well, keep in mind a gain can also be a loss. It might be negative. So what they're going to do is you're going to find your gain for each prize. So if you win the $500 prize, you're actually only gaining $4.98 because you're losing $2 that you paid, and so on and so forth. And so we find the gain for each prize. And then if you don't win a prize, you've lost $2. Then what you're going to do is you can set up this table, which is pretty handy. So you have a row for the gain and then the probability of getting that prize. So it's 1 out of 1,500 for each of the 4 prizes. And then notice that this one's 1496 over 1,500. That means if you don't win one of the 4 prizes, you have 1496 out of 1,500 chances basically of getting a losing ticket. If you multiply the two together, if you multiply the top by the bottom all the way through, you're going to get negative 135, which means you can expect to lose an average of $1.35 for each ticket you buy. So for our example, we have 2,000 tickets. You're selling them at $5 each. We have 5 prizes. So I'm going to go ahead and set up a table similar to the one they had. And this is going to be my gain and my P of X. All right, if I win the $2,000 prize, I'm really only gaining $19.95. And I have a 1 out of 2,000 chance there. Or, sorry, I say that wrong. That's my probability. All right, if I win the $1,000 prize, I really only won $995. 1 out of 2,000. 500. Same probability. 250. I would have only brought home $245. $100, 95. And then if I didn't win any of those prizes, I'd be in the whole $5. And 5 from 2,000 is $19.95 over 2,000. Okay, what you're going to do is you're going to multiply the top row by the bottom row. So keep on doing this. And once you get all that entered in your calculator, that is going to be the sum of your XP of X, which is the mean, which is also called your expected value. All right, and that should be negative $3.08 approximately. Now you're rounding that to the nearest penny. So that means you can expect to lose $3.08 for every ticket you buy. Oops, spelled that wrong. There we go. All right, that's the end of your 4-1 notes. So now you guys should be ready to complete your second 4-1 assignment. Thanks for tuning in.